All right, welcome everybody. This is Power Your Workflow with Git. My name's Patrick Hogan. I just want to give quick credit to these guys, without whom this talk would not have been possible. Scott particularly is like the Git guru. He's written the book. I'll mention that later. But I just want to mention these guys because I learned a lot from them. Okay, my name is Patrick Hogan. I'm the founder of Gallant Games. I have this app in the App Store, and that's pretty much all you need to know about me. So why this talk? Well, everybody in this room, despite the fact that none of you put up your hand for a designer, except for one or two, you're all, in my view, I believe that we are all creatives, right? All of us are passionate, I hope, about creating product, whether for ourselves, for our own apps, or our own artwork, or whatever, or for a client, for business reasons, perhaps, for your company, right? But we all create, and I hope we're all in this business because we're passionate about it. The thing about creating, though, is when you create things, you need good tools. Doesn't matter what trade you're in, you have tools, and if you don't have good tools, the output is often not going to be very good. If you don't have elegant tools, the tools get in your way. If the tools get in your way, they frustrate you. It frustrates your passion for creating. I'm passionate about creating, so I'm passionate about good tools, about elegant tools. And I believe Git is an elegant tool, and that's why I wanted to talk about it here at this conference. Another reason is that it is now the default when you create a project in Xcode. So at least you should know something about this thing that Apple thought was a good idea to make the checkbox ticked when you create a new project, right? My approach for this talk is actually going to be quite technical. It's going to be a technical deep dive into how Git works, how Git thinks about your project, and what it does with your project. I think this is a good approach because it demystifies a lot of the scariness of Git. A lot of people look at Git and they go, whoa. It used to be a lot more scary, it's a little less scary, but it's still pretty scary. And so looking at what Git does, I mean on the downright technical level, is first of all fascinating, just as a developer, you know. Especially when you realize that it was created in 2 weeks. 2 weeks to create this tool. And I mean, it's obviously been iterated on a lot, but pretty much the same tool has been around. So it's fascinating from that point of view, but I think that it's very, very valuable to understand how to use it to improve your relationship with Git. And then, for the second half of the talk, I'm going to get into workflow. This is a 300-level talk. I didn't really know what that meant, so I asked Google. Google told me this. So this is my general approach for this talk. Kind of looks like me, huh? Okay, so this is my approach for the talk. So it's going to come fast and furious, strap in, but you don't have to catch every detail. My slides will be available afterwards. You can get them from my blog or whatever. But I think the overview, just as much as you can absorb, will help you to at least understand Git and understand what to do with it and what it's for. Okay, next slide, I don't know what that is. Version control. Okay, so the thing about version control is, we have this thing called version control. I think everybody at least knows about it, right? And we have workflow in some form. Even if you're not thinking about it, we have a workflow. Otherwise, you're never getting anything done, right? So, I mean, you have a way that you personally work, right? The problem is most developers and most people do this. They put a big fat brick wall between their version control and their workflow because they think version control gets in the way of workflow. I'm here to tell you that should not be the case. Again, if your tool frustrates your passion, your creativity, then it's no good, right? You should be looking for something else that doesn't frustrate you. Okay, history. So way back, several decades ago, we had our computers, and we'd make a file. And then we wanted to version control the file, so we made a copy of the file. And I still do this sometimes. I know all of you do, probably, unless you're exceptionally disciplined. And then we make another one. And then after a while, we can't really figure out which one of these was the one that I last worked on, and which one has the one change that I put in and then deleted. It becomes crazy. So obviously this is a mess. So they made local version control, and basically they put a little database inside your file system. Nobody probably uses this anymore. RCS was around for a while. And then they moved that to centralized version control because you've got to have teams and you've got to have Mike and Jane working together. And so you have a centralized server. But the problem is what happens when your server blows up. Now nobody can work. So distributed version control said, okay, well, let's give everybody a database and we can all talk to each other. And there's no server to blow up. That's great. So that's all unicorns and rainbows. I'm not going to say much more about that. The thing about distributed is everything is local, almost. It's an amazing thing. You think distributed, oh, it's out in the cloud, it's internet. No, everything's local. In fact, no network access, get this, no network access is required for any of these. Any of these Git commands. And I'm not going to talk about Mercurial, but Mercurial is pretty much the same sort of deal. You don't have to do anything on the network to do any of this stuff. And this is what developers do 99% of the time, honestly. Committing, merging, branching, rebase tags, status, diffs, history, bisecting it through debugging, trying to get to a failing test. Even local sync, because you can have local repositories on your same machine. That's a pretty cool trick you can do with Git. So the cool thing is no network required. You can be on a plane 30,000 feet in the air, and you can be working with your project. Nothing has to be different. Advantages, everything is fast, because it's local. Nothing has to go over the wire. No latency, right, to do version checks and all kinds of junk. So everything's blazing fast. There's projects out there with millions and millions of files, hundreds of thousands of commits, and they're still good. They're still fast. Try that with software. Everything is transparent because you have everything locally. Everything, the whole history. When you clone a remote repository, you get everything from day one. All the commits, right down to now. And you can go back and forth. You can see what other developers did. And you never have to talk to the server to get any of that. It's all local. Every clone is a backup. Every clone is a backup. So there's no server to blow up. Anybody who's ever cloned this project, so if you're a team, anybody who's ever cloned it, it has a backup of your project, at least to a certain point, right? That's pretty valuable. That's pretty cool. And you can work offline. That's very cool. So let's talk about storage real quick, because this is something people don't really know about Git too much, and version control. But there's two kinds of storage. Delta storage, which is maybe the more famous one. And probably everybody knows kind of what a delta is, right? Delta between two different pieces of text or code or binary or something. There's also a snapshot storage, which is kind of like taking a zip file of your whole thing. It's also called, for CS nerds, direct acyclic graph. You really don't have to know why, but that's just what it is. So here's the two models. Delta, as you do commits, it figures out the differences between the second commit and the first commit, and stores only that. And for file B, figures out the difference between what you did, stores only that. And that seems like, oh, this is the way to do it, right? Because that's what we're interested in, only changes. Well, it's got some problems there. Git says, no, I'm going to take a snapshot of your entire project every single time you commit. Every file will be committed as one single commit. And that sounds stupid until you see what Git can do with that. The way Git thinks is keep the data model simple, and what you do with the data, smart. Right? Instead of the other way around, trying to make your data model real smart and clever and efficient, and then being pretty much tied to what your data model constrains you to. Git says, let's keep it real simple, and then we can do really, really smart things with it. And it turns out that works great. So here's a spread of a bunch of version control. You can even see copy, time machine, rsync. That's kind of like version control. And it does kind of do snapshots in a way. You can see local, centralized, distributed. Git lives down here. It is distributed, and it is a snapshot storage. Mercurial is actually a delta storage. And there's big arguments on the internet about which one is better. And I won't even get into that. Git is down here. So about Git. This guy created Git, Linus Torvalds. You've probably heard of him. He made this. He got so frustrated with version control that he took 2 weeks out of his life to create Git. Wish I could do that. So this is required viewing. At some point after this conference, or if you have some downtime, well, you can't do it here because Wi-Fi is terrible. But this is a YouTube video. Linus presenting Git to Google. It's hilarious just from a entertainment point of view, because Linus, if you've ever seen him talk, is a very abrasive personality. And I'm putting that mildly. So he insults just about everybody in this talk. That's great. He even insults Google at Google. That's great. So watch this, but he explains his motivation, right? His passion for creating this thing, and why he created to get his frustrations out of the way. And that's good to see why somebody who works on really big projects would need this thing. Git in a nutshell, it's free and open source, it's distributed, it's designed to handle large projects, it's very fast and efficient. So it's actually really good for even small developers, because if it can handle these things, and it's really quick, it gets out of your way, then it's going to be good for you. It's also got excellent branching and merging. This is really Git's defining feature, branching and merging. And if you didn't think that's important, you will by the end of this talk, assuming I get through the 170 remaining slides. Project Using Git, some big names there. Just last week, Linux moved its kernel to GitHub. That was kind of a strange thing, because I always thought that they would like to, hold on to their own servers and stuff, but they actually moved to GitHub. And so a lot of these big projects are on there, and they've been doing great. They've got thousands and thousands of commits. I don't even know how many files, and they've never had a problem. So under the hood, let me have a little sip of water here. So if you go in the console, is everybody kind of console savvy? I'd say, yeah. There's going to be no console demos in this talk, but I will have this kind of screenshot a lot. If you go into your project and you look at hidden files, you see a .git folder. And Git does everything in that .git folder. It's called the Git Directory. If you do a tree, you look kind of like this. There's a lot more stuff in there. And I won't go into, we'll discuss some of what those figures are, but you basically just have to know it's all in there. There is only .git in the root of your working directory, unlike Subversion that puts one everywhere. Everywhere! And they seem to multiply. Like you delete them and they come back. I don't know. Getting rid of them, there's this, Google for how to delete all Subversion directories. You get a million hits because everybody wants to do it. So the Git directory has a configuration file. It has hooks. It has an object database. It has references. And has an index. And that's it. That's everything Git does. And we won't even talk about the first two because I think you all know what a configuration file is, and you can Google how to use that. Hooks are just scripts that run at certain Git operations. And so nothing more I can really say about that. So that leaves these bottom three. If you understand this, you'll understand Git. And they're actually surprisingly simple. So the object database. Best way to think about this is an NS dictionary, or a hash table, key value store, any of those terms. It's basically a key and a value. And that's how Git does absolutely everything. Absolutely everything. So if you can understand that, you can understand Git. So let's say you have content, your value in the key value equation. What does Git do with content? And I'll define what content means, but let's just say a blob of data. Because Git really only thinks in terms of blobs of data. It doesn't really think too much in terms of what that data is. So let's say you have content. What it does is it'll write a little header and it'll say, well, there's a type, and we'll add a space. And then the size of bytes of the content, and then a null byte, and then append the content. Then it'll do a SHA-1 digest hash. You don't really need to know what that is, except that there's probably more stars in the universe than there is a chance that you'll get a duplicate of that. And then it'll compress the same data. Then it'll write it all into a file in that Git working directory under objects, cut off the first two letters of the hash, make that as a subdirectory, and then write the rest in there as a file. That is how Git stores everything. Absolutely everything. It's a file just a file store, like a key value store, based upon the hash. The cool thing is, that SHA-1 digest is essentially cryptographically secure. If so much as a single bit changes in this content, the hash will no longer match, right? And so it's something different. If it's exactly the same, Git knows it's the same because the SHA matches, and it doesn't have to duplicate that data. This means quite a lot of things. It has some implications for distributed synchronization, which is really important. But it does mean that you can be sure that once you put something in Git, it hasn't changed. Git will, with almost every function, verify that SHA hash. And just make sure that, random ray of something from the sun didn't flip a bit on your hard drive and accidentally change your data. So this is called the loose format, just storing a file in like that. So again, it's like an NS dictionary. You got your pointer, which is the hash, and you got your object value. Now this hash is big, it's 40 characters. But actually the way Git works is, if you take a prefix at any level, and it's unique, it uniquely identifies. In other words, there's no other hash that starts with the first 5 characters, for instance. Git will accept that as the identifier for that same content, which makes it a lot easier because you don't have to type out this big 40-character hash anytime you want to delve into Git, which you don't do that kind of thing a lot, but if you did. So it's calling the prefixes unique. That's pretty cool. Git has the idea of garbage collection because, like I said, it stores your entire project as a snapshot every time you commit, which sounds silly. It's like making a zip file every time. But actually it does better than that, as we'll see. But let's say you have a bunch of objects, and Git knows that these are sort of related because maybe it's the same file, and the various commits. On certain operations, Git will actually do like a garbage cut, and you can actually force it by saying git GC or something like that. And what it'll do is it'll figure out the deltas. So actually, it does do some delta. Figures that all out, and packs that into a file with an index about what's in that file. So Git, with doing that, Git can sort of compress your project continually, just kind of, like when you're putting something in a bin and it's kind of fluffy, every now and again you just kind of push it down and push it down. So Git does that to make sure that your project doesn't just bloat, right? All the stuff, your history kind of gets compacted over time. And yet it still can work with that really fast. This is called the packed format. So there's 4 object types in the object database, this key value store. There's blobs, trees, commits, and tags. The blobs are essentially files. So if that's your little project, your files are readme, info, plist, and your main. These become blobs, and they each have their own little hash identifying what they are. And so for the rest of the talk, I'm just going to mention now, I'm going to use short hashes, sometimes only 2 characters, because there's no way I can fit 40 characters on a slide when there's like 50 of them. So sometimes it's going to be just really truncated. So essentially, every file is a blob. And really, this is like I said, how it stores it. There's a little header, it says it's a blob. And the cool thing is you can actually go into the Git directory, look at the files, like unzip them, quote unquote. Git actually has a little tool that you can do that with. And you can look in it, and this is what it looks like. It says blob 109 0 byte, which you can't see, and it has data. This is what Git does with your code. It doesn't do anything fancy to it. It just stores it like this. That's the blob. That's how it does files. Trees. As you might imagine, trees are the folders. So your folders become a tree. And a tree is a little interesting. It does the same sort of thing. It's got a header and 84 bytes and all that. And all it does is store information. It's kind of like a directory listing of the blobs that are, and other trees that are in your tree. That's trees. Commits are essentially point to a tree. So now you can see you kind of get this tree structure going down here. These are your folders and the files. And a commit points to the root of it, usually to your working directory root, and just says, okay, at this point, this is a commit. And this is what it does. It has some information about the tree, a parent commit, or several commits, if that's relevant, who did it, pretty much, who to blame if something goes wrong, and a little message, just saying what the commit is about. So this is kind of the structure you get. You have commits that point to previous commits. You have commits that point to the tree. Tree points to other trees. Trees always end up with a blob, and they show an empty folder. And that's it. So we've covered 3 of the things in the object database already, and it's been pretty simple, I hope, so far. Everybody's still kind of holding on. All right. So tags. So tags points for commit, as you might imagine. That's just so that you can, because remember your commit's not going to have a hash as a name. It just gives it a name. So you can call this version 1. Hey, I've got version 1 committed. And you only tag it sort of milestones of some kind or some marker you want to leave for yourself. And you can imagine what it has. It points to what tag points to. Technically, tags can point at other things, but I've never seen it be anything but a commit. And then what the tag is, in this case, I've named the tag v1.2.0. Who tagged it? Again, who to blame. And the message, hey, 1.2 release, great. Okay, that's tags. Tags write to a hash file in the objects just like normal. And then writes a little thing called a ref, which we'll get to, just with the name, the short name. That's how Git can figure out. So Git looks in v1.2.0, and in that is a 40-character string, which is this. Git then looks in this, and this gives you this. And then from here, Git can figure out the rest of the tree. So that's how Git stores things. I mean, you can kind of see this is kind of a simple idea, but it works really, really well, and it's amazing how much you can do with such a simple structure. So Git really isn't as complicated as people think. The thing about it is this is immutable. Again, everything here, when it gets stored with that SHA hash, that's cryptographically signed essentially. It can't change without changing the hash, right? So it's immutable. You can't change the data, because if you change the data, you're going to change the hash that points to the data. Okay? And that's important for a lot of things. So Git almost never removes data. I say almost in practice, but basically Git, once you put something in Git, once you commit it, it's really, really hard to get rid of it, which is an important thing when you're doing version control, right? You don't just want things to disappear out of your project. So this is quite important. You'll hear when you look into blogs and things, they talk about rewriting history, and that's not really true. Git doesn't really rewrite history as much as it writes an alternate history. It's kind of like parallel universes. It's the way Git thinks about things. So let's say you had a tree in a file, and it's immutable. The file cannot change. Again, the content won't change. So if you did something that rewrote history, quote unquote, Git would write another file and update the pointer to it. But actually, that file will still be there in the Git directory. It's just got nothing pointing to it. It's kind of like a, reference leak. You think in terms of, code. But it'll stay around for a long time, and only certain operations will make it go away. You pretty much have to tell Git, hey, get rid of anything that doesn't have anything pointing to it, and then Git will clean it up. But that's why I say almost. You pretty much have to order Git to lose data that you already said wasn't important. So Git won't lose things that you told it was important. All right, so that's the object database. That's the most complex part of this whole thing. References, because everything's immutable, right? Once you have data in Git, you can't change the data, you can't change the hash for the data, everything's immutable. You need something that is mutable, something that's lightweight, movable, pointers to commits, right? It's kind of like if you have something in memory, you can't move that thing ever. But it's nice to have a pointer that can point at different things, right? So that's what references are for. So you have a tag, and that's immutable, so you have a ref, which again could be like a name like this is my stable branch, maybe this is my remote master branch, this is version 1.0, like I said, that's the name of the tag, so that's a ref. The head pointer, which we'll get to, that's kind of the current state of the current branch. So those are all refs, because those can move around. Those can mean different things at different times, depending on what you're doing in Git. But everything else is never going to change. It's immutable. So let's that's the whole object structure of Git. So let's look at a scenario to see how that works, because I've kind of waffled about it. So this is a project. You've just checked this in. First commit. You've just started coding. You've got 3 files. 2 folders there, and you're ready to get going. So let's say you change this file down there. Can everybody see down there? Because I know it's kind of low. I hope so. So let's say you change that down there. Now what's Git going to do? Because it can't just go in and change the data there, right? It has to do something else. So actually this affects everything up the chain, because if you change even the pointer to the blob, you have to change the tree that contains that pointer, and so up the chain. And basically everything has to change except the refs can just change. So all of that has to change. So what does Git do? It makes new objects for everything that you just did, and writes those in. So it's got the new file down here. It's got a new tree, a new commit, and that commit points to the previous commit, right? So that the rest is still there, and that's how you have track of your versions. The rest is all there in your Git database, and it writes a new branch. It just moves the branch name and the head forward as you do that. So let's show you every time that. Let's say we change that file. Now only 3 items have changed. These still stay the same. So Git will, of course, update those. Write new objects, and again, wrote a new blob, new tree, commit, branch, head. Okay, so now we have this structure in our Git working directory. We've made 3 commits, and at any time we can check out this, or this, or this. So it's pretty simple. The index. This is poorly named, in my opinion. Really what this is a staging area, and this is kind of unique to Git. Subversion doesn't have anything like this, if you're familiar with Subversion. What this is normally the way you work, right, is you code for a bit, and you check that all in. You code for a bit, you check that all in. You code for a bit more, and you check that all in. But what if you forgot to check in? What if you just coded all day, right? And along the way you fixed some bugs, plus you wrote a new feature. And then at the end of the day, you're like, oh man, I've got to check in. Now you got to check in, and what do? You typically would write a huge commit message, if that, just I did stuff and check that in, right? So my favorite commit message is ... Yeah. Okay, so that's a bad idea, right? You don't want to do that. So what do? Git lets you actually have a staging area where you can say, okay, I've made all these changes. Hey Git, what did I do? Git tells you what you did. Then you can say, okay, these changes are for bug fix 1. Commit that. Okay, bam. These changes are for bug fix 2. Commit that. Bam. These changes are that feature I added. Commit that. Bam. And maybe I have a few leftover things I haven't finished with, so I'll just leave that. So the staging area, the index, lets you craft your commits so that you can break them up into small units that you can go back and look at. And you can do other interesting things with them, maybe just pull just that one change and send that to somebody as a patch, that kind of thing, instead of just a whole day's work and say, yeah, just delete that stuff in the other file because that wasn't part of this. So it lets you craft your commits, which is an important thing if you get more disciplined about using Git properly. So how does that work? There's a working directory, there's a repository, which is actually your Git working directory within, or your Git directory within your working directory. There's this index in between the two. So you add things, git add, you've seen that probably. You add that to index. You can then do get status and figure out what you've got in your index, what you've staged. You can sort of add a commit message and things like that. And then you can, well, you do that when you commit. So then you commit it to your repository. And then you start all over again. You can check that out into your working directory at any point. So this, instead of just having the working directory in the repository like you might be used to with Subversion, you have this intermediary step. And that's actually kind of important because it is a part of what Git is all about. So then index is just amazing because you don't have to commit everything at once. This is important. You can stage logical units to commit, and it helps you review your changes. And that's why I said this is really important to Git, because the way Git can help you really with your workflow as we get into that is it can help you become a little bit more disciplined about doing things and then looking at what you did. Analyzing, what are the files that really changed with this bug fix I made? Did I do it right? That kind of thing. It lets you do some code review just for yourself. And sometimes it's just a glance. It takes 10 seconds to look at, the diff of what you did and just say, yeah, that's what I meant to do. And sometimes I've caught things. I'm like, oh wait, there's something that should be in here that isn't in here. And it just kind of jogs my memory. So it can be good. And then let you write your history cleanly. There's nothing worse than looking at a project and just seeing a bunch of commit messages that don't quite make sense because they have all kinds of changes that don't always relate to the same feature or the same bug or whatever. And it's just kind of a mess to figure out what somebody did, especially if you're not the person that did it. Or you come back a year later and look at your history, trying to dig through for something. So getting started, I'm not going to get into this too much because you can Google all this stuff. And there's probably not going to be a lot of time for Q&A in this, but come find me afterwards and talk to me. If you have any questions, I'll help you get set up, get it installed, whatever you need, I'll talk to you about it. So I'm just going to try and give as much information to everybody as I can in this talk. So you can get in it, you can clone a project, pull one down. There's a git ignore file where you can kind of specify which files you don't want to commit to Git, and there are quite a few, dstar, old Subversion project perhaps. Your bold directory, you don't want that, some of your user files. You can Google around to find out what files are good for that. These are mostly the ones I have a few others I think. You know that you can have Git just completely ignore certain files because you don't want that in your version control. You can stage files to the index. That stages with the dot just means everything, the whole project. You can commit. Git forces you to add a commit message. You cannot commit without a message, even if it's ... Okay, which is often why it is ... Git forces you to do that. It'll complain. If you just type git commit, it's going to open whatever your terminal considers your default editor and say, probably Vim or VI, and say, hey, give me a commit message right now. Okay? Don't leave that out. Write something intelligent. Even just a one-liner, just explain what this Git is. And again, if your commits are small and they're crafted, those commit messages are going to be small. They're not going to be a page long with all the rationale of why you did all this stuff. Sometimes you put something in there, but you don't always have to. Branching and merging. Okay, this is the big deal with Git. Okay, so you can create a new branch, say git branch name. That just creates a new branch. Git checkout name is how you check out a branch. Overwrites the working directory. So let's say we have this scenario again. So here we have a project, one commit, one folder, one file. And we make our first commit. Hey, okay, so I'm just going to represent it as that green thing. But that means everything below, the whole subtree below that green thing. I'm not going to worry about talking about files and folders. You guys know what that is. I'm just going to talk about the commit and everything it represents. So we can make another branch, feature, right? And we can check that feature out. And what Git does is creating the feature ref there, branch pointer, and head just means that's checked out. That's where Git is working right now. That is what your working directory represents at that point. If we make another commit, that's what Git will do. It'll make another commit pointer, and you will have needed to add your file or your feature file Git won't track files you don't add. So if you don't add something to Git, it won't know about it. At that point, you can commit it, and you can do that again. If you already have a file tracked, so feat.c is already tracked, if you just add -a, it'll add everything it knows about already. You don't have to do that git add all the time. So we can make another branch. Here's another shortcut way that git checkout -b issue master does all of that. Checks out master, branches, makes another branch called issue, checks out issue. And that's what you get. Now, if you're only familiar with Subversion and maybe some other tools, you're already probably confused because there are 3 branches here. And if you're used to Subversion, 3 branches means a whole lot of pain coming down the road. Okay? With Git, that is not the case. That will not be a lot of pain. In fact, that'll be a lot less pain. Okay, so I'll flip that up there. So we commit a new issue and keep working on that, updating the issue file. So at this point, we can ask Git what's going on, and there's a whole lot of commands to do that type of thing. You can inspect the log, Git keeps a log of everything it's done. You can look at your history and you can find out. But if we looked into what Git understood about our project, this is what Git would see. Sorry if it's a little small, but it's got readme in there, which isn't everywhere. It's got main.c and feat.c and issue.c. And if we look at main.c, we can see it's the same in the first, just in the feature branch, it's the same in the first check-in, first commit, and it's changed in the second commit. And Git knows that. How does Git know that? The hash has changed. If the hash hasn't changed, the file hasn't changed. Git doesn't have to know anything more than the hash has changed. Let's look at main.c up here. Well, it's the same because the hash has not changed. It's the same hash. Feat.c, well, it's added there because it wasn't in the previous one, and it's changed over there. And kind of the same thing. Issue is added and changed. Added there and changed there. So Git knows that just by what? Looking at the hashes, looking at what's in those trees. And that makes it quite easy to reason about this. So let's check out mastery, and we jump back to the common history there. And hopefully the branching is obvious here with the two branches there. So if we try to merge issue, right? So we're sitting over here, right where we began, and now we want to merge this issue in to that history part. Well, Git can look at this and say, okay, look, following the pointers back. Hey, wait a second. This has this. You're merging into somewhere where I came from, my origin, my history. You know, I've been here before. So this is called a fast forward merge, and all Git does is move the pointer. Let me say that again. All Git did was move the pointer. It didn't have to change the tree. It didn't have to change the object database. It didn't have to write anything else to disk except a 40-byte, actually a 41-byte file to move the branch name. Really, really fast merge. Okay? Really fast merge. That is the fastest merge you can possibly do. Writing 41 bytes, actually, well, I guess it writes ahead too, so 82 bytes, I don't know, 82 bytes. That might take too long. Okay, but now if we ask Git to merge feature, now we have a problem because feature looks back at its history and says, well, I haven't seen issue anywhere, I haven't seen this hash anywhere along the way. So this is not in my history. So this is called a non-fast forward merge. And what it has to do is go and find a merge base. So where do our paths sort of diverge or converge, I guess, in history? And what Git can now do is something called a three-way merge. Git is really good at doing this, which Subversion is not good at doing. So it does a three-way merge, and it can basically figure out a lot of changes, ways to merge code particularly, on its own. And then in some cases, it's going to ask you, but this will probably work pretty well, and almost always just succeeds. But what does Git actually do when we do this? What's the end result going to be? And how does Git figure this out, right? What's the magic that makes Git merge so well? Well, again, it's the hashes. It always comes down to the hashes. Well, Git says, hey, I've got readme in both of these. It was in the original. The hash hasn't changed in either one. Simple if logic. And bam, it writes the same file. And actually, it doesn't even write the same file. Because it doesn't have to write that file again. The hash hasn't changed. The content hasn't changed. All Git has to do is write the entry into the tree. Right? It doesn't have to write a new file, just an entry. So, very fast again. That's how Git figures that out. Another case. Okay, well, main hasn't changed in issue, but it has changed in feature. If we look at the hashes, Git can say, well, since it had the same hash back there as it had an issue, I'm going to assume that feature was a change. It was the newer one. And so let's it's going to pick that one out of the two and write that. It's done that for you. It didn't even ask you. It didn't have to ask you. It knew what you were doing. Then it can look at those and say, okay, now we got a problem. Both of those have changed, but they're different files. So, and they aren't in the other one, so therefore Git knows it can just put them there. Again, Git hasn't asked you a single thing. It just said, yes, boss, done it. Okay, really fast, no problems, no conflicts or anything of the kind. Git just did the merge. Let's rewind a bit. Let's say, what if main had changed in both branches? Changed from the original. Now we have a problem. This is called a merge conflict. And at this point, if you were doing Subversion, you would probably be throwing your screen against the wall or something. Yeah. With Git, however, it'll just give you this, which kind of looks scary, but Git basically says, hey, you're trying to do something which I don't understand. I don't know how to fix this, because you have two changes in two branches. You're going to have to help me out here, please. And so it tells you what to do. It basically says, well, there's this merge conflict. Fix the conflicts and then commit what you've done. So if you say git merge feature, I should update it. If you say git status at that point, it would say both modified main.c. So it tells you both branches that you're trying to do modify this file. If you look into main.c, you'll see that. It puts out the standard. Subversion does this too. Most other things do that, that style of thing, where they basically say, well, this is what's in one branch, this is what's in the other branch. You got to pick one, right? So you pick the one, you take out the bits that get added, and then you might use a merge tool for that. And I'll talk about that later. But then you add the file, and you say, basically signifying to Git with that add that, okay, I've made the decision, I've edited the file, I've chosen between the two bits that you said, which one is it? Now take that again and commit it. Now you have your merge. So now the cool thing is you still have your branches, so you can keep working on feature. And let's say you work a bit more on feature, and you check out master again, and you merge feature. And this is called a reintegration merge. And this is definitely something you can't do with Subversion. Git doesn't go all the way back to the common merge base. It just finds the first common merge base in history, the closest one. And so the changes between these two and that are very small, because you just did a merge a moment ago. And so Git can do a lot less work to merge that. And so the nice thing is, you can be working on like a feature or something. Maybe, let's say, giving a concrete example, maybe something that involves internationalization. And your translators are getting bits and pieces to you over months. This stuff takes time. You can have this I18N branch where you're doing that in, and you can just, every time a French translator gets you a couple of things in, you put it in, and you can just merge it into the master. And then your German translator gets a few things in, you can merge that into master. You can keep doing that, and the changes stay small because you just keep reintegrating. And Git doesn't have a problem with that. You can keep just doing that, which is really good for long-running features, long-running development, anything like that. We can now delete git branch-d feature. And Git will actually do that safely. It won't let you do that if it knows it will lose work. So you can delete that, and you can delete issue, and now you kind of have a clean, just you're on master, you have a clean, and you have this history, but Git at that point knows what's going on. It's all nice and clean. If you did want to delete a branch, maybe it was experimental or something like that, you can just use a big -d, and then Git will delete with extreme prejudice. And it'll just blow it away. And so if you did an experiment and it didn't work out, you can just blow it away, and your project is fine. Git hasn't destroyed anything else, and you can just keep going. Branching and merging. Okay, so what's this good for? You can isolate experiments on a new branch. You don't have to be afraid of branching. That has implications. If you don't have to be afraid of branching, you can make these branches. You can isolate what you're doing in there. You can do your work development, and you can just merge them in when you're done. I said work units, it's kind of similar, but instead of blowing away an experiment, this might be a bug fix. And you can just isolate that into a separate branch, you can do that work and then merge it in, it's not a problem. You can parallelize, your team can work in parallel really easily on different branches. You don't have to kind of have all these tips, all these tricks to kind of work on the same branch, but not really be working on the same branch. And I don't even know how to do it, because it just gets too complicated. You can have long-running topics, which is just like a long-running feature like internationalization. You can do a hotfix really easily in a new branch. I'll quickly mention merge versus rebase. This comes up sometimes. You've seen what a merge looks like. It's you've done 3 commits, and you have another branch, and they work. And so this is the same situation. What would happen in a merge? What should happen in a rebase? Merge is what you do most of the time. It'll just commit them as a merge commit, and that's what your history will look like, kind of a tree structure or branching structure. Rebase is a tool for cleaning up history, and you kind of really have to know what you're doing with it. It's one of those things that quote-unquote rewrites history, rewrites an alternate history, as you'll see. What it does is, well, it says, okay, I'm going to take the delta between these 2 changes, and I'm going to rewrite them on top of this one. And so basically you get this. One single branch, essentially, or one single work tract flow, and you have this sort of lost piece of information here. But that has been recorded here, so it isn't really lost, and Git will hold on to it until you blow it away later. Okay, remotes. This is where the sort of distributed nature of Git comes in, and this is now where you start talking about network usage. A remote essentially is a URL. It's really all it is. Git supports these. We won't talk about those 2 because they're not recommended, they don't work as well, and I think they're probably even deprecated or will be. But these are the ones you'll use more frequently. SSH and file are for pushing. In other words, you're sending files over. And the rest you can do pulls with. So you'll notice that the Git protocol is actually it's just really good for, it's kind of like read-only. So is the HTTP, even HTTPS is kind of more like a read-only protocol. With SSH, it is inherently authenticated, right, to do SSH. So that's how you would do authenticated Git stuff. And then file, the local one, which can often be ignored. People don't even know it exists sometimes. I find it to be one of the most useful things, and I'll show you a cool trick you can do with that. But you can push and pull to file. So, okay, big diagram. Let's say you have a company server. Now you have Anne's computer and you have Bob's computer. And they both clone, Anne clones the project. Bob clones the project down there. Now they both have copies. You see Git stores origin/master. That's just how it says, this origin is kind of its keyword for this is the canonical remote. This is where it came from in the first place when I cloned it. And stores that as a branch, really. And does that on both computers. So then Anne does some work. She commits that work. Bob also does some work in parallel, commits that work. But Bob is a little faster, so Bob, he's going to push first. So what Git does is have a little conversation between the server and the computer, the local, and basically says, well, what's the hash that you've got latest under master? What's the hash that I've got under origin master? Okay, they match up, so I know what to do, right? Just rewrite my data on top of that. And so it matches real nice. Moves the reference up to record where the server's at. So Bob's computer now knows the server is at B2. And so now Anne comes along and she says, hey, I want to push to master. Push to origin. Same conversation happens. The problem is, the server says, hey, Anne, I'm on B2. And Anne says, I thought you were on C2. So the computer says, sorry, can't do this. I need to know where you're coming from. So what Anne has to do is she has to fetch. She can go fetch, pull those changes down from Bob, and you can see the divergent branches now. Now she can do a merge. It's up to her to merge in the 2 different pieces of work, get to A3, and now she can push. And now Git says, yeah, that's fine because I know the hashes were the same. I know where you're coming from. You've done all the work, and now the server will accept it. So the server doesn't allow you to push things that don't make sense to it. So.
Fetch actually did a merge?
No, fetch just got everything. And actually, there's a slide that says, but pull is the same as fetch and merge combined. And it's actually a bad idea to do both at the same time. You should manually do a fetch, then do all the merging and things you need to do, and then push it back up or do whatever you need to do. So anyway, just to finish off, Bob can make another branch for a bug, commit a couple things, push that up, and Anne can pull that down, and anyway, boring stuff. But basically, it just means that work can continue and there's no real conflicts happening there. So git pull is fetch and merge. And I recommend highly, and people a lot smarter than me recommend highly, that you do a fetch and then you do a merge. Unless you're the only person working with that repository. If it's a team thing, do a fetch and then do a merge. If it's your own project, you're the only one that wrote to it, so a pull is probably okay. Because if a pull kind of makes certain assumptions, and if a pull blows up on you, it's a little hard to get out of. It's not It's not going to kill anything. It's not going to blow away your project or anything. But it just means you've got to do a little bit more work to get it back to a stable or clean condition. So do a fetch and merge. It's just cleaner that way. Collaboration. Okay, so now we're getting more into workflow, perhaps, and hopefully the internals didn't all shock you or put you all to sleep. And you can forget pretty much everything I just said. It was just to demystify it, to just point out it wasn't as scary as you thought. It's basically a file, key value store. Do you have a question again?
I think I missed the point where fetch, so you got the fetch and then you do like does it get it in a different branch? And
Yeah, it just stores it in your Git working directory. Remember, the Git working directory can have all kinds of branches in it. It can have different work in different states, and you can check any one of them out at different times. You can do merges between them. So you always have everything that, everything from the point that you did the pull or the fetch. You have everything on your machine. The whole history of the project, all the branches that were on the server, not just the one that you're working.
So if I have my changes and then I fetch some other changes, and fetch does not do merge.
Yep.
So
if you do a fetch, Git will not fetch it to your working directory. So you still have the files in your working directory, right? Or in your branch. When Git fetches it, it fetches it into another branch. Remember, even if the branch was called, like your master branch is different from Origin's master branch. So it actually pulls them. It pulls the changes down into a separate branch, which you can then merge together, and then push up.
So it pulls it down in origin master and then you merge origin master and master when you merge.
Yeah, and it probably won't, if you're working in a big team, it probably won't be called origin master. It might be origin develop or something like that, right? But it pulls it into a separate remote branch, as Git calls it. But it really just behaves like a normal branch, and you have it locally, and you can do everything you want to do with it. Okay, collaboration. The centralized model. This is what, in most companies, they're still going to work this way just because they're used to this. Even if they've switched from Perforce or Subversion or whatever, they're typically still going to work like this. So they'll have a shared repository, and all the developers will push and pull from it, basically. And they kind of stomp on each other a bit, and this only scales to a certain point. Like after a certain number of developers, you start getting conflicts, and you can work in separate branches, but Git can only help you so much before this becomes a bad idea on a big project. So something like Linux, for instance, the kernel, there's no way this is going to work, right? There are thousands, hundreds of thousands of developers working on the kernel. All their changes don't make it into the actual canonical kernel, Linux's kernel, but they're all working on it, right? So that model doesn't scale, and it's not just open source projects, even big companies, some projects, you just can't scale it that way. So Linus has the dictator model, so he's the dictator, right? The benevolent dictator, as you can call it. So he has an authoritative repository. That's his repository. That's the one everybody should know about. Well, he has his own personal one, but this is the one that everybody sees out on the internet. This is the one that right now is on GitHub. Okay? You have 4 developers out of 100,000 probably that want to work on some change, and so they will pull down from the repository into their local repositories. They will work independently. But they can't all push up to Mr. Dictator, because if 100,000 people push changes to Linux, he'd get really upset. So what he does is he has lieutenants, and he talks about this quite a bit in that YouTube video I pointed you to, why and how he does this, and he has trusted people under him. And so each of them, one guy will be over the network part of the kernel, and another guy will be over the audio part of the kernel. And so developers push changes to the right lieutenant, obviously, and then they sort out all the merging and things that need to happen on a certain scale, and then they push it up to him. So I think Linus said he only has like 12 guys under him in this tree. So because you have this tree structure, essentially, this can scale, right? You can have hundreds of thousands of people working under, down, and some changes never even make it up back into his stuff. But theoretically, hundreds of people can push. Different people might just do little patches, little fixes, little changes, and they can all just push it up to the right person, and it filters all the way up to eventually get back into the authoritative repository, assuming that it's been okayed along the way. And Linus has said pretty much he will just accept anything his lieutenants do. He trusts them. That's why he only has 12 of them, or however many there are. And he can trust them, and they only have maybe 10 people they trust. And those 10 people maybe only have people they trust. So it's kind of a trust model. Peer-to-peer model. This is kind of how GitHub works. So you have, every developer has their own private repository and a public one. So and that's how I work. I have, on my laptop, I have a bunch of repositories for my project. That's what I work in. even here in a hotel where the Wi-Fi isn't working, I can work, right? I've made commits. I don't know, I think I've made about 5 or 6 commits while I've been at this conference to a project. So I just did it locally, right? I haven't pushed anything up anywhere, but I've been able to do it. That's in my developer private. Now I have a few public repositories on GitHub, and every now and again I might push up to it, and other people can pull down. So developers can pull from the other people's public, and this, assuming what's in public is relatively stable, and what you have in developer is kind of not that stable. There's an integration model, which is kind of similar to the Dictator model. You have it's kind of a merge between the two. Developer privates, developer have publics. You have an integration manager, one guy whose job it is to merge all these changes. He pulls from their publics, and he pushes it to authoritative repository, and developers pull it out. So, kind of similar to the Dictator model. And really the takeaway from this whole thing is, the bottom line is, there are many good collaboration models. You customize for your team, your project. There's no single one way. Yes?
Yeah. Might have answered the question I was going to ask. If you have, if you're working on an internal project with some other people, you have a shared repository, and you want to say use some open source stuff from GitHub, is it possible to have that? You want to check in a copy, a clone of that repository into your shared repository, but then can you keep it also in sync with the stuff on GitHub so that you can basically keep synchronizing changes, merging in GitHub changes, but also...
Yeah, you can have multiple remotes.
Is that multiple remotes?
Yeah, and you can pull it from them at any time. So your job might be at the company, hey, keep our copy of whatever open source project up to date.
Right.
You know, our code up to date. And so your job might be every week to go and fetch from the GitHub repository, and then, you know, with the Git tools or your merge tools or whatever, look at what the differences are and pull in the right ones, do the merge into your own branch, and then from your branch probably push into your servers. So you know, your job might be to do that. You'd almost never pull from the remote straight to your company's remote. It'll always go via somebody who does the integration work. Yeah. But Git allows you to do all that type of stuff, right? And really, you can make up your own models. That's kind of the motto of this slide. You can just make up your own model, whatever works for your team. And the amazing thing is, GitHub posted a post this a couple weeks back on their workflow, and I'll get into workflows next. Their workflow is exceptionally simple. It's got 2 branches. I couldn't believe it. I thought these guys are the Git pros. These guys know everything there is to know about Git. And yet they keep a really simple model, and it works for their team because of the way their team works, the tools they have for deployment, and I think they're under 20 people, so that it works for them, right? But your team may be different. In fact, you may be one guy, right? And so your model is different. And your model for working with yourself and your model for working with another team member if you're on another project is different. So again, you have different models, but Git lets you do everything, and the distributed part gives you the option. Right? You're not forced into the centralized single server authoritative model thing, right? You can have this peer-to-peer thing, which is how most open source projects work in some ways. You know, there's all these forks, and it's not that scary. You know, people used to be kind of like, oh, I don't want to fork with my project out there because I want to be the one and only, and that's stupid. You know, why not have all these other forks? And if you like what they're doing, pull in some of their stuff, and if you don't like what they're doing, let them do their thing. I mean, that's why it's open source. Like, why did you release your code if you don't want people to mess with it? So, workflow. First, let's talk about a non-workflow. But this may seem familiar to some of you. You make changes, you're all happy, you make more changes, then you break the code base, then you rage for a while, then you fix the code base, and then you repeat. And does this seem familiar to anybody? Yeah. So this is really a non-workflow, right? This is why you need version flow. So a bad workflow is just to create changes and commit changes. I have to admit, sometimes I do that. But you know, small projects, maybe prototypes, this is the way to do it. At the game jam tomorrow night, or whenever it is, this is probably what I'm going to do. I'm going to create changes, commit them, like really fast, all the time. Just so that I have these little snapshots, basically, of what I'm doing. But this is probably not good for, you know, professional project. So, kind of a bad workflow, but that's typically how people might use version control. Basic workflow would be to create changes, stage the changes, again, coming with the index, and crafting your commits. Then reviewing your changes in some form, even if it's a 10-second glance at what you did today, and then committing those changes, right? And sometimes breaking things into multiple commits, that type of thing. So that's a basic workflow, and that might be all you need to ever do, kind of as a lone developer. So workflow pro tip, commit early and commit often. Really, I mean, I forget sometimes, but I try to every little feature, every little thing I change. If I add a new class, I make a commit. Why not? Why not take a snapshot, you know, if you can? And if you have the right tools, it's like, maybe you have a console open, it's like hitting the up key and enter, that type of thing. Like you can have it on a one line or something. So you can do this quite often. And then commit units of work. This is important, so you can go back and again, see the little bits and pieces you did, especially when you're running into a bug and you're trying to figure out where you introduced the bug. I was trying to debug some OpenGL stuff I did the other day, and it was a nightmare because at some point I just got a black screen and I had done too many changes and no commit, or not as many commits, and I couldn't figure out where the point was in my project where I made the breaking change. So the smaller those units of commits are, the easier it is to go back and find that one change that broke everything. So this is a good workflow. Don't panic. I will explain. And I will just say that this, you might call this a perfect quote-unquote workflow. This doesn't apply to anybody in the room, like the whole thing. But the aspects of this will show you how Git's branches can be used to power your workflow. This is really where the title of my talk comes in. And hopefully I've made things a little less scary to this point where this can kind of begin to make sense to you. So I'm going to talk about the parts of that, primary branches. These are the ones you spend 99.9% of the time in. You have your master branch. This really should reflect the production-ready state of your code. So this would be what you show to your client, if you're a contractor, perhaps. This might be what you give to alpha or beta testers or your wife or whoever, like, you know, if you're coding, your husband, perhaps. Any ladies in the room? Oh, one. There we go. So this is kind of like, okay, this is what I'm ready to show someone, maybe. Well, this is the stable state of my project right now. It always exists, never goes away. The develop branch is a second branch. This is kind of where you work on. This is the latest development state for your next release, and you can base your continuous integration on this if you're doing CI. There's any talks on that at this conference, but if you do CI, this would be a good branch to do it on. Ultimately, the stuff you do in develop ends up in master. That makes sense, right? It always exists. Develop never goes away, so you don't like remake a develop branch every time. You have one develop branch, and that's where you do work on. So again, for the lone developer, this is probably what you'll have. This is what I do most of the time. I start developing on a develop branch. I work a couple commits. I'm ready for release now, so I make the 1.0. First release, I tag it with a name so I can find it again. And then I work a bit more, and I'm ready for release again, and I tag, make a next release to master and tag the next release. And I keep doing that. So this is really simple, right? I mean, and this is kind of a good way to work. If you're working on projects, this may be the best, all you need of that whole big graph. But the nice thing is if you work in this way, it sets you up for having those other branches, which can be useful. So let's talk about some of them. Ready for release again? Okay. Secondary branches, feature branches. I do recommend this though, even if you're a lone developer. Fine-grained work in progress. So a feature branch might be something like, gonna add the particle explosion for when an enemy gets blown up in a game. Or I'm gonna have a feedback form for my app in the help screen. That might be a feature branch. And so you branch off the latest develop, wherever develop is right now, branch off that. It merges back into develop and then gets discarded. You may merge in more than once, like it's not really a good reason to do that, but there may be a case. But really, once you merge back in, once you're done with that feature, it makes sense, you merge it into develop, now you're done. Now develop, again, represents the latest development state of your project. But you didn't mess up develop by working in this other branch. This other branch was a separate unit of work. You could scratch it, you could blow it away at the end, and just say, hey, this didn't work out, that feedback form. The PR guy said, not a good idea, we're gonna get too much hate mail. So I'm gonna blow that away. Boom, it's gone. All right, 10 minutes. All right, let's fly. Okay, or just discard if it's failed. Short or long running, typically one developer in developer repositories only. So development master may be on your central server, but this won't be. Its name convention could be like feature / cool new feature. So this is what it looks like. You don't see master here because the feature never talks to master directly. It always goes through develop. So branch per feature, you merge a feature. You always branch from the latest point, and then you merge again. That's a long-running feature, maybe that language translation stuff. Merge in, and you're done. Secondary branches, again. Another one is a release branch. Latest release candidate state. So maybe if you do a lot of QA, a lot of testing, you have a big testing team like we heard at the lunch panel, preparing work for release, last minute QA testing, bug fixes happen here. Sits between develop and master, so it's actually like a buffer between develop and master. Branch from develop, merges back into master and develop, which is actually important. Discard after merging. So, you can study this more in my slides later if you're really interested or can talk to me. Start developing, ready for release. You branch from develop to say, hey, I'm preparing for release. Development can continue though. You're doing final QA fixes, add your release notes. Then you merge into both master with a tag saying, hey, this is 1.0, and you also put back in develop, so develop stays current as well. Ready for release, and then you've blown it away, obviously. So you can do that again. So every time you're going to do a release, you have a separate branch, just your QA guys, maybe your bug fixers work on that if you're in the team. Hotfix branches, like release, preparing for a new release, but resolving emergency problems with the production. Merge back into both master and develop, discard after merging. Naming convention, hotfix, for instance. And there's a project called Git Flow that actually does a lot of this stuff. So Google for Git Flow if you're interested in more of this. Anyway, I'm just trying to show you ideas here. This is all just like, hey, you might find this useful, you might not. So let's say you find a bug in your master branch. So now you branch it from your master, you do some fixes, and you put it back into develop to make sure your bug fix ends up there, and you make a new 1.1 version, right? So that can happen again. So I'll just skip to the rest. Support branches. This is maybe an iffy one. Only really big projects might do this that have legacy enterprise clients, that type of thing. Similar to master and hotfix for legacy releases. What do I mean? Okay, I'll skip all this because it's basically saying the same thing. But let's say you have master first release, and now you've made a second release, right? You've already got down there. But now you find a bug in 1.1, and you still have some guy, maybe on iOS 3, still got an iPhone 3G, complains about something, and you're like, well, it's an enterprise client, I have to fix this. What do I do? So you branch from that old commit, right? That old master version, make a fix, find a separate branch, support branch, and you can branch from that. And the idea is this now becomes a second pod. It keeps going, it never goes away. And you're now supporting that 1.0 range, and 1.n, 1.x range for the legacy clients. But you can keep going with 2.0 and so on. So that allows that. It's more for enterprise type stuff. So that's the whole graph demystified for you, pretty much, really quickly. Yep.
Your master branch pretty much only ever contains a one commit that's a merge commit with a tag.
Pretty much.
Why not just tag? Because you can branch after any tag.
Why not just tag other branches?
Yeah.
Because you may mess with those, and in some situations you may actually do. It's nice to have like one branch that is clean. It only has the grouped changes for a version, instead of like a bunch of little snapshots, maybe some history mangling and all kinds of stuff like that. We can talk about it later. I want to really try and finish in the next 5 minutes here. Public-private workflow, I'll really go through this fast. This is another way of thinking about workflow. You can have public branches, and the idea is basically that the public branches are really clean. That's kind of what we're talking about. Public branches are really clean. So they're well documented, they're linear, they're immutable. In fact, you do a lot of like Git rewriting to make sure that that branch is always clean, always just public. You have a private branch which is kind of like disposable, malleable. You keep blowing them away. You never merge directly into public. You always make a separate branch. You do the stuff reset, remake, squash, and man, scary things that basically clean up the history into that exactly what the master branch is. Really just single commits, really clean, really easy for some other developer to look at and not see 150,000 commits with like random things happening. They can just see one commit, and then you commit that into public. So you can see that better. So bottom line, every project is different. Again, custom design your workflow. Branches are your Lego blocks. If you take nothing away from this talk, take that away. Branches are your Lego blocks. That's the thing about Git. It gives you these branches that are cheap and easy to merge and mess with and blow away and do whatever you want. And you can come up with all kinds of workflows and things that work for you personally and work for your team. That's fantastic. And that really is the building block to make your workflow awesome with Git. further reading for that stuff. Let's talk about some tools. Choosing Git. There's a site called whygitIsBetterThanX.com. Check it out. There's Git SN, the website. If you don't know what Homebrew is, check it out at least, because this is a really cool way to install a lot of stuff. It's kind of like Mac ports, but better. Made by the Ruby community, and they're a little more, how shall I say this? A little more concerned about doing things right. And that makes it really easy to install Git. This is got a profile file you can edit to add like your username and email and stuff to configure Git. You can Google that. There's a thing called bash completion. If you use that, and this looks all really scary, but what it does is it gives you a command prompt that looks like this. So it tells me what branch I'm in right now, which is really cool. There's this book called Pro Git. Read it by Scott Chacon. There's a free version online, but I recommend you buy it because it's cheap, and this guy's awesome, and you should support him. Learning Git, he's got this site called Git Ref. Kind of explains some of these commands more simply. There's Git Immersion, which is a great thing done by EdgeCase. Kind of like a tutorial way, like work through the steps to learn Git. A good way of doing it. Hosting Git, GitHub is awesome for public repositories particularly. I think they're awesome for paid repositories if you're into that. They gave me a promo code, 360IDFPH. I'll tweet this later. And you can get a free micro repository for a month. And just check it out. Just mess with it, play with it, see if you like it. Okay? There's also like stickers and stuff back there from them. There's a whole bunch of stuff, so you can get some of that. If you're more in a company, there's a project called Gitolite, which my sysadmin likes, and he installs this for our local private repositories because we like to keep things on our own servers and some of our projects. And so Gitolite lets you basically set up team hosting on your own machine if you're into that. Dropbox, here's a cool trick. DIY single user hosting. Single user hosting, don't do this in a shared Dropbox folder, please, and then blame me for it afterwards. So what I do is I have something called repo or repositories in my Dropbox, and I create a repository like that, make a directory. I initialize, I go into it, I initialize it with bear. I go into my project that's on my computer, and I add a remote called Dropbox using the file protocol. And, let's skip the next step. Basically, the next step is profit. But you can push and pull now to this other repository in your Dropbox, and my Dropbox takes care of syncing. I've never had a problem with it, ever. That's how I get free hosting from my Git repositories. Hey. It works great. Tower is the best single client for Git. Not just on Mac, but I think period, like at all, it is the best client. I have a free version of Tower, it's like $60 to give away to somebody. The way I'm going to do that is come and talk to me, give me a business card. If you don't have a business card, I'll write down your name or something, and I'll pick somebody, randomly, I'll do it randomly. Or maybe if I like you. No. I'll do it randomly, and then I'll give away a copy of this. There's a discount code, IDF to 11. That gives you 10% off if you're interested in buying that for the next few days. And then using Git, the GitHub has their own client, but it only works with GitHub. It's okay, it's pretty cool. I've used it a little bit, I'm not as experienced with it. I use Tower. Kaleidoscope is good for diffs. It's really awesome, even does image diffs for artists, if you want to see like differences between the two images. It's pretty cool for that. Merging Git it's kind of awkward, but it's free, called diff merge. Helps you to merge really weird merge conflicts. It can help you out with that. It's cross-platform actually. And that's me. So I've been Patrick. You guys have been awesome. This is my Twitter handle, my email. Email me if you'd like anything. I'm at Gallant Games. Promo codes are up there if you missed it. So yeah, come talk to me if you have any questions, need help with getting set up. I'm happy to help you out during the conference. I know I've thrown a lot at you guys, but I wanted to pack it in because I know that you can't absorb everything, obviously. But I wanted to expose you to all of it because now you can, if you had interest in any part of it, you can go and research it. Or email me if you have questions or whatever. And hopefully this has been useful for you to at least see what Git can do, and that is very flexible, that it has these the branches that are just really amazing for doing a lot of different things and different workflows, supports a lot of workflows, and if you do it, it's kind of like kind of like test-driven design or unit testing. If you get into the discipline of using it the right way, it actually starts to modify how you work. and it sort of forces you to work in certain, think about, hey, I'm working on a new feature. Let me stay focused on this new feature instead of scatterbraining all over the place, or or reviewing what you did in the day. Like, yeah, I did two bug fixes, 3 features. I'm going to break those into different commits, and I know what I've done in the day, and I have a record of it, that type of thing. So, hope this has been helpful to you guys. Thanks for attending.